at 5.6. And I'm going to give you a definition of scientific notation. It's going to be a Hubertism. In other words, it's not going to be in the book like this. Scientific notation is placing the decimal to the right of the first number greater than 0. Placing the decimal to the right of the first number greater than 0. Now there's two questions that are always asked here when I put that definition up on there. One, well, how do you know where the decimal is, and how do you know where it's going to be? Well, which way do we read? Left to right, unless you're from the Middle East, Masalama. We read left to right. So I'm going to put an arrow down here. On a whole number, where is the decimal on any whole number? On a whole number. It's not in front of, it's where?
Behind it.
Behind it. So where is the decimal, even though you can't see it, on this whole number?
Behind it.
Behind the last what?
The last number.
0. It's right here. So you need to take your highlighter or a colored pencil and you need to color that decimal red or something, because that decimal, since it's not there, is assumed to be right there at the end of the last 0. Now we read from left to right. So where is the first number greater than 0? Okay, I want everybody to put their eye on the 2 and go from left to right. Where is the first number greater than 0? Y'all know what greater than 0 is, right? It means 1, 2, 3, 4. Okay, start from the left. Start from. I'm gonna put a line right there. Start from there, and I want you to look from left to right and tell me the first number greater than 0. 2. So I got to put the decimal to the what? To the right there. That's where I need to put the decimal. The red is where the decimal is. The blue is where the decimal needs to be. Write that down. The red decimal is where the decimal is, and the blue arrow is where the decimal needs to be. So I've got to move that decimal 4 places. Let's count. I didn't say any direction. I just said 4 decimals because I don't want anybody to get the cart before the horse. We ain't talked about that yet. 1, 2, 3, 4. So I need to move my decimal 4 places. Does everybody agree with that? 2.7 times 10 to the blank 4. Now, at this point, I'm going to take a highlighter, and you need to take a highlighter, and I'm going to highlight this blank right here. And I'm going to go up here, or somewhere. I'm going to draw an arrow, and I'm going to put mentally. Now, what does mentally mean? In your head, right? Mentally thinking, mental thinking, okay? Which way do I move the decimal to get original? You write that out however. Which way do I move the decimal? This decimal right here, I'm going to highlight it. We're doing it mentally. Which way do I mentally move that decimal to get it back to the way it was in the original problem? To the right. What is right? Positive or negative? Positive. So you're going to put a positive right there. Now this right here is going to come in handy because I'm going to tell you what students do as far as missing these problems. Students do not miss the problems turned into a big number in scientific notation. They do not miss the problem turning scientific notation into a big number or a small number or vice versa. That's not what they get wrong. What they get wrong is the problems where you actually have to multiply or divide by scientific notation. That's what students get wrong, all because of this sign right here. Okay? So just bear with me, and every time I ask you that, you think about it. Which way do I move the decimal to get it back the way it was? Which decimal? This decimal right here. Which way do I move that decimal in my head to get it back to the way it was, to the right? Now, why do I do that? Well, it's very methodical. I'm giving you a step-by-step how to do scientific notation. I do every one of my scientific notation problems this way. Therefore, the methodical, the repetition, step-by-step is always there, to where even if it's a decimal, or if you're multiplying, or if you're dividing, or if it's a big number, you know what to do. All right, so let's go with a small number. 0.0000576. All right, I want you to take one highlighter, and I want you to put where the decimal is. And then I want you to take another highlighter and draw an arrow where the decimal needs to be. Then you're going to move that decimal and then put a blank how many places you moved it. So where is the decimal? We see this one because it's a decimal. It's a small number, so the decimal has to be there. There's the decimal. Where does the decimal need to be?
In between the 5 and the 7.
Good job. So you're going to move 1, 2, 3, 4, 5. So that's going to be 5.76 times 10 to the blank. And how many times we move? 1, 2, 3, 4, 5. Okay? And then you ask yourself, which way do I move this decimal in my head to get it back the way it was? To the left.
To the left, that would be negative.
That's going to be a negative. And that's your answer. Now, again, 95% of the students will get this one right and get this one right. Well, Hubert, why are you making a big deal out of it? Well, you'll see in just a minute where students get it wrong. So that's what scientific notation is. Placing the number to the first number, placing a decimal to the right of the first number greater than 0. All right, so let's look at one, and let's see where we, go off the beaten path a little bit. So how about this one? How about 3.0 times 10 to the 14th power times 8.0 times 10 to the 3rd power? This is a scientific notation problem that you do in steps. When you have a multiplication or division problem with scientific notation, you multiply or divide the numbers, and then you add the exponents, because you are multiplying. When you multiply, you add exponents. When you divide, you what? Subtract exponents. So here we're multiplying. So what is 3 times 8? 24. So I go over here and I say 3.0 times 8.0 times, and then I put 10 to the 14th times 10 to the 3rd. And 3 times 8 is what? Times 10, and what's 14 plus 3? And we're done, right? Yes or no? We done?
No.
No, why?
Exponents.
No, not the exponent.
Oh.
Where is the decimal right now?
Oh, the decimal. At the end.
It's on,
Behind.
it's right at 24. Where does it need to be? It needs to be in the middle. So move it. I want y'all to do that. Go ahead and do it. Just draw a little arrow. You're moving it one place. I'll even tell you how many places you're moving. You're moving it one place. Now, the correct answer is 2.4 times 10 to the 18th power. Is that what people get? Nope.
Yeah.
Most of the time they get 2.4 times 10 to the what? 16th power. And the 16th power is wrong. Okay? So that's why I'm telling you. Just because you've been doing it a certain way does not mean you've been doing it the right way. Here's how we do it. I've got the decimal right here. That's red, meaning that's where it is. And I'm going to move it one place. Notice what I don't say. What do I not say? I don't say which way I moved it, because that's not important right now. So that's going to be 2.4 times 10 to the 17 blank 1. Now, which way, take my highlighter, which way do I move this decimal to get it in my head, to get it to look, to get it back to the original form?
To the right.
To the right. Thank you for enunciating. And that is 2.4 times 10 to the 18th power. I gave this problem. Yeah, I don't even want to tell you what they did. I gave somebody this problem after we did several examples. I gave this problem to somebody, and this is what they did. Y'all ready? Yeah. You don't even want to think about doing this. It took them a half a page. I walked by and I said, "What the heck are you doing?" "I'm doing the problem." They didn't only miss the boat. They missed the train, the boat, and the plane. The whole point of showing you scientific notation is that you don't have to do this crap. Oh, Lord. Some people could break an anvil with a banana. All right. Huh?
Should have given him a bigger number.
Yeah. Yeah, just turn it into big-ass numbers and just spend a half a day doing all those zeros and filling out those place values. Because you'd have to do 0, 0, 0, and then 8 times this, 0 times 0 times 24.
You keep
That's so many
freezing.
place values, it would just be just ridiculous. What did you say? I'm sorry.
I said it keeps freezing.
Our screen's been frozen for a while.
We all know what it is. Okay.
Questions?
Yeah.
Yep. I'll take you out and bring you back in, okay?
Okay.
Having problems today. The last class was having problems. I need to mention it. I think it's just something glitch or something. I don't think it's that big of a deal. We usually don't have this problem. Oh.
Anderson.
All right, how's that? Is that better?
Yes, right now.
Mr. Robinson, when did you decide to show up?
I've been about 10 minutes.
All right, how was lunch? Did you have a good lunch?
I had to go pick up my mama.
Oh, got to bring mama into it. No, that's good. I'm just kidding. Oh, man.
Like jockey light.
I didn't know if you had 5 flat tires or not.
I'm trying to get her moved back up this way, so I have to drive to Anderson whenever she needs me to come down there.
Oh, okay. Well, next time you in Anderson, you can come by and take the class
That's what
here.
she was saying. That's what she was saying.
Yeah, I don't care about that. Y'all, if you live near, there is a student, this is no joke, okay, I'm going to make fun of a student. There is a student traveling to let's see, what campus is she at?
Our screen's turned on.
Yeah, well.
She is going to the Pendleton campus every day, and guess where she lives?
Anderson.
Easily.
Oh,
No, what
She's
she
going to
probably
the
doing
Pendleton
is-
campus every day. She lives in Easley. I told her, I said, get your butt at the Easley campus and go in that room and turn on the TV. Ain't no sense in you driving all the way to Pendleton. You know, there's some people at Pendleton that believes the world and the sun revolves around the Pendleton campus. There are actually people at Pendleton that tells you not to take classes at Anderson, Easley, or what do we build the damn things for? You know what? Why
The
we got
Pendleton
people?
campus, you cannot find a parking spot anywhere.
Well, oh no, I despise going up there. And my department head, oh well, you need to come up here. I said, there's a thing called Skype. You know, we can have meetings. You know, oh I don't want to do that. Whatever.
I know a few
Walk around
summers
like a
ago, I used to
T-Rex. Just
park-
pull your arms up like this and walk around like a
Tell me
T-Rex.
something.
It
Anyway,
makes me so mad. Anyway, I'll shut up. So, let's do a nerd. I'm going to let y'all do this one so you can get discouraged and hopefully quit. All right, let's do 45.0 times 10 to the 15th power divided by 3.0 times 10 to the 4th power. All right, y'all do that one. And if you can't do it, just write it up as being a failure in life. I want to know why Zaxby's can't get my dadgum order right. I went up to the
You're
81.
still on that.
I went up to 81. I said, I'm going to give Zaxby's one more chance.
Listen, I don't work
Okay,
at that.
28 bypass screwed my order up. Highway Clemson Boulevard screwed my order up. Highway 81 screwed my order up. So I said, I'm going to quit going to Zaxby's. I'm going to quit.
Okay, just come tonight. I'll work tonight.
No, I'm not. I'm done. All right. So I had to go meet somebody up on the north side of town. I said, well, I'll just go to Zaxby's and I'll sit down and I'll wait on them and I'll get something to eat. But I had to go pick up my son and he likes chicken fingers, so I ordered 5 chicken fingers. They got that wrong. I ordered 5 chicken fingers. And I don't know what is so difficult about rolled in hot honey mustard or rolled in barbecue sauce. I ordered, there was nobody there. Nobody was there. There was no customers there. It was like 3 o'clock in the afternoon. There was no customers there. It was just me. I walked in. I said, I'm going to sit over here. I need to go, but I'm going to sit over here and wait on somebody. I'd like to get 5 chicken fingers rolled in hot honey mustard. Okay. Ding, ding, ding. Ring it up. I go get my drink. I come back. I go sit down. She calls the order. I go up and get it. I come back.
What you get?
5 regular fried chicken fingers.
That ain't gonna happen this time.
No, they're not supposed to. It's supposed to be rolled in honey mustard.
I know, but I mean, that ain't
I just don't understand it.
What did you think?
Huh? I threw it at him. No, I didn't. I'm done. I'm done. I'm done. No more. If my son wants chicken fingers, we go to Publix, and that's it. I'm not going. Or we go somewhere. We go out there at Ingles and get. I'm not going to Zaxby's anymore. I'm done.
I'll work tonight.
Nope. I'm done.
I know next time.
Tell your manager I'm done. I'm not. I'm tired of it. And if you go to Zaxby's, I think they actually take the wires apart off the drive-through speaker. And I think the manager goes out there, and if it's clear as a bell, he'll go out there and cut them so it's not clear, so they can't. I don't understand it. They need new vice presidents or something. I don't know. I'll shut up. Breathe. Back to the breath. 45 divided by 3 times 10 to the 15th divided by 10 to the 4th. Now, I like y'all, so I'm going to do this one for you. Times 10 to the 11th. I did that one for you.
That's what I've got.
Now, yeah, I thought I'd be nice. What's 45 divided by 3?
15.
Are we done? I had a mumble and a...
I said no.
Okay, good. Why are we not done? Because the decimal is right there, and we got to move it right there. So that's 1.5 times 10 to the 11th. Oops, sorry. 11 blank 1. Which way do we move this decimal in our head to get it back the way it was?
To the right.
To the right. So your answer is 1.5 times 10 to the 12th power. A lot of people tell me, well, Hubert, I was taught differently and I'm getting the wrong answer. If it ain't broke, don't fix it. If it is broke, fix it. If you're getting the answer wrong and you were taught that stupid, if you move it to the left, it's always negative. If you move it to the right, it's always positive. If you're getting them wrong, that's exactly what I was trying to tell you. You've got to learn what scientific notation is and what you're actually doing. It isn't a pattern. I get so frustrated when these teachers teach, oh, well, if it's a small number, you're going to move it to the left, and if it's the right big number, you're going to move it to the right. But then when you get to one of these problems, you don't know what to do. Because of this little thing right here, this is why students get this problem wrong right there. They don't get the 1 wrong. They don't get the 11 wrong. They get the sign wrong between the 11 and the 1. Capiche?
Capiche.
Now, what about if you add or subtracting? Well, that's easy. Why is it easy? Because you can't add apples and oranges and get apples. When adding and subtracting, scientific notation, remember, like what? Terms. No yawning in class.
Sorry.
You don't do it no more. All right? Like terms. If I have 1.2 times 10 to the 4th, and I'm adding 3.8 times 10 to the 4th, what do I do with those 10 to the 4th? They just come down. What's 2x plus 3x?
10.
Okay, let me ask that again. I'm not being rhetorical. I want you to answer me. What's 2x plus 3x? 5x. Did I do anything with the x's or did I just bring them down? Just brought them down. These are labels. When you're talking about like terms, these are labels. 1 box of cereal plus 3 boxes of cereal is 4 boxes of cereal. 1 box of cereal plus 3 boxes of cereal is not 2 cans of beans. Okay? If you have a like term, then you just bring it down. And then what is 1.2 times 3.8? 5.0, Hubert. Thank you for the interaction. Now, I can show you that by doing this. supposed to be 1.2. What happens to those zeros? They what? They just come down. And then what's 12 plus 38?
15.
Which is 5.0 times 10 to the fourth. Okay, remember, when you're subtracting and adding scientific notation, you just bring them down. What if you have this, Hubert? What if you have something that's different? What if you have 1.2 times 10 to the fifth plus 1.2 times 10 to the sixth? You can't do that by scientific notation. The only way you can do that is actually to put the zeros in there and what? Do the math. So you would have to go, let's see, 1.2, 1, 2, 3, 4, 5. 120,000 plus 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There you go. You'd have to add 120,000, or let's see, 1,200,000 plus 120,000, which is 1,320,000. Okay, so if you have different, and you're adding or subtracting different, you have to go old school, and you have to do it the old way. Now, you can use your calculator, but my purpose here is not to show you how to use a calculator, it's to show you properties behind it. Okay? Question here. All right? Time for another example. This is a test question. You got planet A. You got planet B. The distance from this planet to this planet is 5.9 times 10 to the 16th miles. Everybody with me?
Mm-hmm.
You got a spaceship that can travel at 5.16 times 10 to the third power miles per hour. How long will it take you to go from point A to point B? Now, there is a formula that is good about distance. What is it? Distance equals what? Distance equals rate times time, or distance equals speed times time. What do we have? What do we have and what are we looking for?
We have
The speed and the distance.
We've got the speed and the distance. So we're trying to find the what? The time. So you need to solve for t. So what is t equal to if you solve for it? How do you get rid of multiplying by r? Divide by r, Hubert. That's right, class. So t is equal to what? Do not make fun of my mouse writing.
Distance divided by
D divided by what?
R.
D divided by r. Now go ahead and do that. Take the distance and divide by the speed. Rate and speed is the same thing, but don't tell a physicist that. because a physicist will have a cardio infarction if you say that. Just telling you. Go ahead and do it. I want you to do it. I'm not going to help you. I'm going to let you do it. And if you can't do it, then you're just a disappointment to everybody. So, what are we going to do? We're going to take 5.9 times 10 to the what? 16th, and divide by what?
5.16 times 10 to the
Good.
third.
5.9 times 10 to the 16th, divided by 5.16, you're going to need your calculator, times 10 to the third. What's 16 minus 3?
13.
That's going to be 10 to the 13th power. And somebody divide 5.9 divided by 5.16. What do you get?
1.14.
1.14 times 10 to the 13th, what? Hours, because what happens to the miles? What happens to the miles when you put them over each other?
They cross out.
And that leaves hours. So, does that tell you anything? No. Because what do we talk in? Okay? We talk in terms of years, don't we? Or in terms of weeks or days, months. So how many days, how many hours are in a day?
24.
24.
Okay, so there's 24 hours in one day. And how many days in a year?
65.
365 days in 1 year. So if I cancel the days out, cancel the hours out, somebody take 1.1, okay, let's do this by scientific notation. 1.14 times 10 to the 13th divided by 2.4 times 10 to the first times 3.65 times 10 to the second. So the bottom is going to give us 2.4. Somebody multiply 2.4 times 3.65 for me.
I have a question. Where'd you get the 4.5?
Where's 4.5?
4.5 days?
I
Oh,
don't
that's
see.
under 1 year.
365 days.
Oh, that's not what it shows on ours.
Yeah, it says 45.
You are kidding me.
No, I wrote that down too. I said, I don't know where he got that from, but okay.
Hold on. Okay, is it gone?
Yeah.
Yeah.
How's that?
That's
That's
better.
better. I was so lost.
I suck. Times, so somebody multiply, that's be 10 to the third power. What is 2.4 times 3.65?
8.76.
8.76. And then 13 divided by 10, that's 10 to the 10th power. And then somebody take 1.14 and divide it by 8.76.
.61, we'll round it, so,
Point six
yeah,
one what?
6.61.
0.61
Yes.
times 10 to the 10th. So that's going to be 6.1 times 10 to the 9th power.
Is there a way to move the screen because like you're over the writing?
Let's see.
Yeah, you can move, hit that little, there's a little white arrow on the right hand side. You got to look for it. Look to the right of my picture. Right there. Click on that. And then you can move that over to the other screen.
Whoa. Okay.
Do you have just one screen?
Yeah, we just have one screen.
Okay, just keep it minimized and move it over. Move it as you need it. There you go. I thought they had two screens up there. Well, maybe
No,
by
this
2000.
one's really
What,
big.
2024? 2024, you may have two screens. So just put it on the wish list. Because we're Tri-County Technical College. We believe in technology. We still
Bare
have
minimum.
teachers. We still have teachers using overhead projectors. So, how many years is that? Well, 6.1 times 10 to the 9th. That's going to be 6, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good gracious alive, they're going to have to put you in daggone cryogenics. It's a long time. But your spacecraft don't go 500 miles per hour. What do they go? They go like 1,500 miles per hour, 15,000 miles per hour. They go really fast because they're traveling in space. Okay? There's no friction. You feel good about yourself. Question, gripe, complaint. Okay, I'm going to let y'all go early today because I'm going to let y'all go and work on your homework because next week I want y'all to ask questions. I know, when does the homework end?
13.
I need to fix that, so I'll go in there and fix that right now. While y'all are packing up, I'll go fix that.
Did I get the answer?
Yeah.
What?
That's the 1 times 10. 6.1 times 10.
In the middle of it.
All right, where are y'all? 155. There y'all are.
To the 13th.
I want to change. I want to go see if this does it. I'm going to experiment here and see what happens. Courses. I'll go to the coordinator course down here. I think that, no, not that one. There it is. Math 155 right here. And I'm going to change in here and see what happens. I bet it don't do it. I'm going to go to change dates. Yeah, I'm going to make it on the 9th now that you said that. 5.1.
So much homework, dude.
5.2. Well, we ain't even close to doing it yet. I'm just extending it besides, I don't even know when we're going to take a test. I'm just extending it.
I thought you were making it shorter.
6.1. Yeah, that's what I'll do. I'll make it due tomorrow. How about that? Is that better?
No. Please.
You said the 9th, right?
No.
No, right now I'm just going to extend it to the 20th.
That works.
Now, I don't know if it's going to do that on both of y'all's classes. Let me see if it does that. Okay. Go back. While I'm at it, let me stop the recording so it can be